Okay, so Pythagorean theorem in 3D shapes, and let's see if you can see these pictures. 3D shapes are three-dimensional, so I'm going to show you a couple of examples in just a second. So let me zoom it out. So if I have this box, let's see if I can zoom it out anymore. Yep, there we go. So I have this box. Notice this side is 10 inches, this is 5 inches, and where's the other one? This is 7.5 inches. So that's actually this picture I have drawn here. So notice it's this box sitting like this. Okay, this is 10 inches, 5 inches, and 7.5 inches. So if I look at that, and I wanted to find, like, if a ruler or some object would fit in this box. So I'm going to go ahead and zoom in. Sorry, I hope that's not loud, me moving that thing. So if I have my box, I have 10 down here, 5 here, and 7.5 here. And I wanted to find out if a ruler would fit in this box. So again, the longest side would be from there to there. So I'm going to see if a ruler will fit in this box. And in order to do that, I'm going to have to use this. Well, notice that is that's called a diagonal. So it's from this corner up here to this corner opposite. So that's the top, back, and then it's the front right. So diagonal is from opposite corners. So if you think about this object, and of course I said using Pythagorean theorem. So using Pythagorean theorem, that's a hypotenuse of a triangle. But it's sometimes kind of hard to see what triangle we're talking about. So notice, we know that that is a leg of that triangle, that back edge back there. And then the other part of that triangle is from the corner just below it to the same corner. So that's my right angle. So do you see, it's kind of, and that's why it's 3D shapes, there's that triangle coming out at you. So, I don't know if you could see it in the last one. So notice, we actually need to look at it a little bit differently. So, if you look, we're trying to find this length here. So, like if I was trying to see if this box would fit in there, if it was a little bit longer, I should have grabbed a ruler. But so we're using this here. Notice it's tied from this corner to this front corner up here. Okay, so that's that diagonal. So you could think of it as almost like a laser or a string coming from that corner down to there. Shipping companies, or not, I guess not the shipping companies, but companies like Amazon, Walmart, Target, all of those always have to, like, they have certain boxes that they use, and then they have to do math to figure out, and I'm sure it's not somebody sitting there doing math, I'm sure it's a computer program, but where they can see if items can actually fit in the box. Either diagonal or just fit in there perfectly, like side to side. So they do need to know the diagonal to decide if something will fit. So let's actually find that measure. Find the length of the diagonal. So we know that this box, all of these measurements here are 5 inches. So if we wanted to, we could write all the way around. This is 5, so this is 5. Well, if that's 5, then that back there is 5, and this up here is 5. Well, this 10 is actually this front edge. It is not that right there. So then if we think about this length, we cannot find two missing things at the same time. So we're missing or wanting to find this diagonal, but in order to find that diagonal, we need to know the two legs. So we have this leg, and we need to find that leg. Well, if you think about that bottom, so if I draw the bottom of the box, so this is just the bottom. We know that this is 10 and this is 7.5, and if we're trying to find that right there, notice it's the diagonal of the bottom. So this is 7.5, so this side would be 7.5. So we actually have to find, so our first step, step 1, is find the diagonal of the bottom rectangle. So we want to find the diagonal of the bottom rectangle, and of course we have this leg and this leg, so we need to find the diagonal, which is also the hypotenuse. So then we're going to use, this is A, this is B, so we're going to use 7.5 squared plus 10 squared will equal C squared. Hopefully you've been doing that enough that you know that. So I do 7.5 squared plus 10 squared is 156.25 equals C squared. And then I want to take the square root of 156.25. So I get 12.5 equals C. So that means this is 12.5, meaning this is 12.5. And so I could take the box, let me zoom out again. And again, this is the bottom of the box. Notice that was the 10, that's the 7.5. So this measure right here, from this corner to this corner, or if I look at it this way, this corner to this, no, sorry, this corner to this corner, underneath the rope, should be 12.5. Okay, so now once I've done that, now my next step, I'm going to use pink. So step 2 is find the diagonal of the box. So then I have this triangle. So that 12.5 is down there. The 5 is here. So then I'm going to find that length right there. So of course use Pythagorean theorem. We'll use A. That 12.5 is now the B on the diagonal of the box. So we will do 5 squared plus 12.5 squared equals C squared. So 5 squared plus 12.5 squared is 181.25. Take the square root, and you get 13.46291.202. And we'll round this to the tenths. I can't spell. So then the 10th place, so that means 1 decimal. So look at the 6. The 6 makes the 4 go to a 5, so it'd be 13.5 equals C. Okay, so that is this distance right here. That's that diagonal. Should be 13.5. So of course it's the longest measure in the entire box. Okay. All right, so now the next one. So now we're going to look at a cylinder. So this is an old Lysol container, sorry. So we have this cylinder, and I'm trying to decide what can I fit in this cylinder. So we're going to make a diagonal that goes from this corner up here down to that bottom edge down there. So we're going to be looking at that measurement right there. So and at the end of the video, I'll kind of show you how to draw these shapes, so if you want to see that. Okay, so we have this cylinder. Notice this 2.25 goes from the middle to the edge. That's called a radius. And the 8 is the height. And we're trying to find the diagonal of the cylinder. Okay, so if we're trying to find this diagonal right here, notice you can kind of see most of the triangle. So our triangle, and I like to draw the triangle outside of the 3D shape just so I can visually see it without everything else. So we know the height of the triangle is 8. We know that the radius, remember radius is only halfway. Radius is half the circle. So if this is 2.25, if I want to know, or if I want to use this leg to find the hypotenuse, I don't want to use 2.25, you have to double it. So double or multiply by 2. So 2.25 times 2 would be 4.5. So the whole distance right here is actually 4.5. So then we would have 4.5 squared plus 8 squared. This would be A, this would be B, equals C squared. Okay, so let's do 4.5 squared. Hit 20.25 plus 8 squared is 64. 20.25 plus 64. Or, I've been doing it in the other parts of the video, I just wanted to address it. You can type it all in at once. Notice it gives you the same answer. So 84.25 equals C squared. Take the square root, take the square root. So 84.25 is 9.178779875. This time I'll round to the hundredths. No, I'll round to the nearest whole number. So if I want to round it to the nearest whole number, that would be 9. So I'd need to look at this 1. So since the 1 is smaller than 5, it would just stay 9. So we'd say 9 inches equals C. So the largest thing I can have fit in that object is 9 inches. Well, technically 9.1. But 9 inches is the largest thing I can fit into that cylinder. So that was rounded to the nearest whole number. Or whole inch is what it'll say sometimes.